this. Thank you, Sumit. We always forget to. So thank you so much for reminder. So yes, this CFA, what we do basically, you test the model which you have devised in this exploratory factor analysis. So you do this in another set of individual. So you administer this questionnaire to another set of people or the students, and then you do the confirmatory factor analysis. So just to give some more concept regarding this exploratory factor analysis, remember in exploratory factor analysis, we said that all the factors will load on each factor. That's why I said that you hide loading less than 0.4. That's why in the column you will not see. That means in this example, you can say if there are 6 items in a questionnaire, there will be 6 factor. So assume there are 6 items, and we talked about the total variance and then the shared variance and unique variance. So assume that each item has a total variance of 1 unit. So the factor 1, if the item 1, it is getting loaded in different amount in all the factors. Similarly, factor 2 is also getting loaded on all the factors, but again, you can see the amount. And the amount, the factor loading, we have decided that if it is more than 0.5, then only we will call it as a significant loading. That's why it keeps, like in this case, you can see factor 5 and factor 6. All the factor, they are going in a very minimal amount. But in factor 1 and 2, you will see that most of the items, they are getting loaded very strongly. So this is the pictorial representation. And like if you do the EFA, you will find that only 2 factors, they have come up very strongly, because all the other factors, they are getting loaded here in a very weak item, all the items. So all the items are getting loaded very weakly. That's why maybe these 2 factors are the strong factor. So now in this case, with this personality example, there was one question like, I feel comfortable around people. So if I take a response on a 5-point Likert scale, and 1 is disagree and 5 is agree and maybe 3 is neutral. So suppose this one item is there, and now you see from the theory, I have an idea that personality has 5 dimensions, and we know the 5 dimensions are openness, consciousness, extraversion. Openness is how open a person is to new ideas and experiences. Consciousness is the how goal-directed, persistent, and organized a person is. Extraversion is how much a person is energized by the outside world. Agreeableness is how much a person puts other interests and needs ahead of their own. And neuroticism is how much sensitive a person is to stress and negative emotional triggers. So these are the 5 personality traits. And now if there is one question, like I feel comfortable around people. So maybe, can you think that openness of a person will affect this response to question? If I say that I feel comfortable around people, and if I'm an open person, so this comfortable, can openness of a person may affect this question? So yes, Sugandha is right. You are very right. If I say, can consciousness is of a person will affect this response, because consciousness was what? That the ability to be a goal oriented. So if I say that I'm comfortable around people, can consciousness of a person will affect this response? So it may be yes. Or if I say that I feel comfortable around people, so can you say that I'm an extraversion person? Because extraversion is what? I get very happy by the outside world. So maybe that extraversion will also affect this question. Can the agreeableness of a person affect this response to question? So yes, it will definitely. And can neuroticism? So yes, answer will be no, because neuroticism was in the negative term. So in that case, it may be there or it may be there. So that's why we should measure this effect. We measure this effect statistically. So if you are measuring this in a mathematical form, and if you decide to group the item, So now let's see how we grouped it. So in step 1, we decided to measure a construct for which we required a tool or a scale. And then what we do, we either translate an existing validated scale with or without modification of its content, or we developed a new scale with a maximum possible item. And we have discussed these things. In step 3, what we do, we use the translated scale and we decide whether it is like we make a structural model, whether it is there should be a single dimension and it should be a multiple dimension. Then in step 4, we do the pilot testing of these questionnaire on 10 to 30 participants. We take out the valid consistency, internal consistency, and content validity. And then after, whether it's a newly developed or it's a previous one, in both the case it will be the same. And again in step 5, we conduct a pre-testing or the validation study using a translated scale, and then we use that translated scale to do the CFA, which is the confirmatory factor analysis, just to say whether the model which we have proposed, is it showing the same structure in the another set of data. So for the newly developed scale, if the scale is very much established and the translated version is available, like in case of a PHQ-9, it is available in almost all the language and it is validated, and it has already been validated at several places. Then in that case, you can directly decide to go for CFA. You don't need to do maybe the EF, because the translated version is there and it has been tested. So you may take a call, but again for newly developed scale, definitely you should do a EFA or a PCA. PCA will be again on the previous established one. So you will do a EFA on this as a validation technique, and then you will do the CFA. So in step 6, you collect the data again to test your proposed model, and then you see that whether the CFA is good or not, and either you accept or you reject that model. So in this case, we will see this general health questionnaire. So we may see like we have seen regarding this general health questionnaire, its factor. So we have taken this, we have a data and we'll see how many factors it is extracting. So this was the question. We have seen this was a unidimensional. Ideally, this was a unidimensional scale. So in this unidimensional scale, if you need to do a mathematical clubbing, so there are many options possible. If you don't want to use statistics, there are many options possible. So like you can club question number 1, 4, and 3 together. You can do question number 5, 6, 11, 10 together, and likewise. So there will be a lot of combination, but statistically there will not be a many significant structure of this length. So it depends that how this exploratory factor analysis, how many factor it is showing. So in this case, like one of the dimension was social risk. You can see that one of the person, they have described this as a 4 factors, like social dysfunction as 1, not 4, 3. Then anxiety and depression as 2nd, and loss of confidence as 3. So let's see now. I'll go back to the data of that GHQ, that is the general health questionnaire. So we did this general health questionnaire data analysis yesterday for reliability. So if I want to do the factor analysis, you can see here, I'll go to the factor. I'll go to the exploratory factor. I'll move these variable to this box. Then I'll check for these assumptions. I will use this option of principal axis and oblimin, that is the oblique rotation, maybe on the basis of eigenvalue. And then I will see how many factors. So you can see that it has taken out 6 factors. But again, we will not say that it is a simple structure.
And eigenvalue should be greater than 1.
Okay, I have not done that. That's why it is coming. Thank you. Thank you, Bhavna. So now it will change. That's why I was worrying why there were 6. So now, yes, you are right. So it is, you can see that it is one factor. But again, if you change it to maybe the any other, maybe if I change it to say Varimax, then maybe the number of factor, again, it is the same. So if any, if the rotation is Varimax and if number of factor is coming 1, you may change the rotation method and you may see it, the other, this thing also, again, you will see there is one factor only. So in our data, it is showing only one factor, but we have shared the references that they have seen that they were extracted three factors. Like in our statistical anxiety, we had three factors, whereas the original questionnaire, they suggested 6 factors. So it depends on the data. So now coming to the confirmatory factor analysis. So from the exploratory factor analysis, what I have seen, that the questions, remember we have seen the, this was the, so from exploratory factor analysis, I have decided that I'll remove few factors. I'll show you on the basis of what. So if this was my exploratory factor analysis, can you see that this A10 is not getting loaded on any other question? Can you see here? This A10, I'll show you. This A10 is not getting loaded on any, because it, you will see the uniqueness. It is very high. Similarly, if you see any other, so A10, I have written that I am not going to keep this in my item because it is not getting loaded on any factor. Similarly, if I come down and see this O4, so can you see this O4? This O4 is also not getting loaded on any this thing. So that again, if I go up this O9, so O4, O9, this is also not getting loaded. So I have written it that O4, O9 I have to remove. And then again, this A10 I have to remove. And then if I go up and so this N4. So I am removing these 4 items now because they are not getting loaded on any other factor. So now what I'll do the confirmatory factor analysis. So for confirmatory factor analysis, I have taken another data set. I said that you cannot perform the confirmatory factor analysis on the same data set. You need to take some other sample. So you open, what you do, you go to this factor, and in factor, there is an option of confirmatory factor analysis. So you open this confirmatory factor analysis button, then you can say that this is the factor 1. So now from E1, all the E1, it will be loaded on factor 1. So I will go down. I will shift from this E1 to E10 to factor 10. So I will keep this in factor 10. Then I will add another factor. So I have added another factor, and now I will move this N1 to N10. So N1, N4 was not there. So maybe I will first shift it, but again, I have shift this to this new. So you have to keep on adding, but again, I have decided that I will not keep this N4. Ideally, I should have administered this question, not keeping that N4 in the item. But since we are using the data which the Jamovi has shared, that's why this N4 was there, but I have removed this item N4 because this N4 was not getting loaded on any other factor. Now I have added new factor, and the now new factor is the, after N, it is the A. So A, I have decided A10 I will not take because it was not getting loaded on any other factor. So I have taken up till this A10, and then I have shifted this, but again, I will move this A10 back to, so I am not taking A10. So I have not taken N4, I have not taken A10. And then if this again, I will have to add new factor. So you should remember the clubbing of your factor. So in factor 4, now I will move this C. So this C1 to C10, I have moved here. And then again the next O1 to O10. But I have not created a factor, so maybe factor 5. So I need to add a new factor, and then I will, in factor 5, I have moved this. But again, I have to move this O4 and O9 back to this window because I have decided that I will not keep this item because they were not getting loaded. So have you understood this process which I am doing? Have you understood why I have removed these items like A10, O4, O9, N4, etc.? So you will see here, you will not find this factor 1 was from E1 to E10. Factor 2 was, yeah, N4, you will see it is missing here. Similarly, A10 will be missing here because in the exploratory factor analysis, they were not getting loaded on any factor. That's why we have not taken that factor in our confirmatory factor. We have not taken that item in our confirmatory factor analysis. Now I'll go to these options. So with this, can you see that there is something appearing of this sort? So this is your factor loading. So factor 1 from E1 to E10, 2 from N1 to N10, and similarly. So now focus on first this p value. So this is the estimate. This first column which you are seeing here, this is the estimate. So this estimate is the unstandardized coefficient. This is the standard error, and this estimate by this standard error is the z value. This one is the z value, and you will see this p value shows that all these items were significantly getting loaded on the factor 3. So in confirmatory factor analysis, you can think that it makes a regression equation. It is based on the regress, that is the multiple regression. So in multiple regression, remember that we used to have a dependent variable and independent variable. In this case, this construct or the underlying construct, that is the dependent variable, and these factor are the independent variable because the factor are getting the item are getting affected by the underlying construct. So we can say that all the factors, all the items, they are getting loaded significantly on these factor like factor 1, 2, 3, and 4. So this is saying that it is good. Now, if you see the standard estimate is the standardized beta coefficient. So you can see that 0.6, 0.6, these are the good value. So all the values are good. That's why it is coming significant. So you can export this table and you can comment. So from this table, we can say that all the factors are getting loaded, all the items are getting loaded on the factors significantly. Is it okay to all of you? Are you getting up till this point? Because I will go very stepwise. Is it okay up till this point? One of you can say yes. Harna is saying yes. Haripriya is right. Yes, yes, please. Do you want to say something? Anyone was saying something? Okay, Poonam is writing yes. Okay. So if you have understood up till this point, then I will go to the next part. So now you can see, if you come down, you will see this is the factor estimate. So basically this, what is this factor covariances? These standard estimates. So here also you will see that this standard estimate, focus on this standard estimate, and this tells you like the variances between these two factor. So factor 1 and factor 2, factor 1 and factor 3, factor 1 and factor 4, and factor 1 and factor 5. So it consider in between factor, it takes it as 1, and then with respect to that, it keeps all other variances. And this is a standardized estimate. Again, with the p value, you can say that all the factor, there was a covariance between the factor except this. So if you see this 0.22, so there is no covariance between the factor 2 and factor 3 because p value is not significant. Rest are the p-value is significant, but it is not going to make any difference. That means the whatever factor, so factor 1 was maybe the agreeableness and neuroticism. So definitely it will have less, no correlation, no covariance, because agreeableness is opposite to neuroticism. And minus sign is about the reverse question, reverse coding question that we have answered. In the original tool, you will see that there were items which were the reverse coded. So the reverse coded, we discussed this yesterday also, that reverse coded questions will be negatively correlated, because the option, it will highly disagree to agree, it will give you the opposite answer. Okay. So this was the second factor estimate. So now come down, and this is for the model fit. Now I will take this model fit, it comes automatically. You will see here in estimate, if I go, these things like test statistics, I have taken this test statistics confidence. This confidence interval is up to you. If you want this confidence interval of test statistics, you can click that. Otherwise, the important one is the factor covariances and the standardized estimate. Then you come to the model fit. In the model fit, you see there are many options, but most commonly we use the chi-square test. There is a CFI, confirmatory factor index. There is a TLI, which is known as the Tucker-Lewis index. There is a RMSCA, which is known as the root mean square error of approximation. So we take these 4 measure. Now, before I explain this, I'll just show you one slide which I missed here regarding the confirmatory factor analysis, how to interpret the decision of this confirmatory factor analysis. So this CFA, the values, what should be the value of these CFA statistics? So in model fit statistics, the chi-square value, whatever we obtain from the, it should be similar to the EFA and it should be significant. The second is the model fit statistics. So this, the second model fit statistics is the comparative fit index, which we call it as a CFI. So the value of this CFI, it ranges between 0 and 1. And we say that if the value of this CFI is more than 0.9, it indicates a good fit. The next is the Tucker-Lewis index, because these two come together. So this Tucker-Lewis index, its value also the same we take, more than 0.90. And then there's another measure which is known as the root mean square error of approximation. And this, if its value is 0.01, it is excellent. If it is 0.05, it is good. If it is 0.08, it is mediocre fit. But we can take it up till 0.1 for mediocre fit. So this was the model fit statistics for assessing the model of confirmatory factor analysis. Now coming to this, if you see this statistics of model fit, you will see that the p-value is significant. So you can say that this model is okay. But remember, from EFA, we have seen that it was able to explain only 40%, all the 5 factors. They were able to explain only 40% of the variance of the, because of that personality trait, that construct. So if you come down and see these fit measure. So what is the value of CFI? It is 0.746. The value of TLI, it is 0.732. So we say that it is not a good fit. Why? Because the value should be at least 0.9, but it is less than that. If you see this RMSCA, this is again at least 0.08 should be there. Otherwise, we say that this is not a very good fit, but we will see. Now we have to do some modifications. So this was the model 1. Because if you see the result, I'll just show you that slide again. So this was the, can you see this model? So we express this, you can see there are other measures also, but maybe you can keep this chi-square degree of freedom, CFI, RMSCA, and then you can, these measure it up to you. I have not taken these measure, but you can take that. But just to have an understanding, the first model which I proposed, this was one which I have shown you. Now you can keep on changing the model and you can keep on writing, and then the close fit indices will show that is the perfect model. So how to come to that perfect model? So now if you come down, here you will see in the model, apart from model fit statistics, there are options of additional output. So in the additional output, you will see there are three options. There is a residual observed correlation matrix. There is an option of plot, which is the path diagram. And there is an option of modification indices. So this modification indices, initially, if you open your Jamovi, by default, it is 3. So now what are these estimates? So this residual observed correlation matrix is, I have kept this value as 10 here because by default you keep this value as 10. And this residual observed correlation matrix means you take the correlation. Can you recall that residual? What was that residual? So in logistic regression or in chi-square, whatever was the expected and whatever is the observed. So the difference between the expected and observed, we call it as a residual. Similarly, here in this correlation matrix, there are some observed correlation. And based on model, this software will project its correlation. So there will be expected correlation. So the difference of the expected and observed should, actually it should be 0. But we take up till 0.1. So if the difference between the observed and expected is more than 0.1, I have given it command that it will show you in the matrix. And then this modification indices. So what are these modification indices? These are the indices which says how much it is basically the chi-square value. So these modification indices, it tells you between the what are the modification, if you modify this, how this model is going to change. So first we will see this matrix. So this I will just explain you. There is not much of very use because it is a very huge matrix. Can you see? And here all the colors, red color, that means the correlation between that particular, the residual of A2, and if you see this one, the first one, the E1, that is more than 0.1. Similarly, this is 0.14. So all the correlation where the difference between the expected and observed is more than 0.1, it will highlight those values. So you just have to, we don't do anything on the basis of that. The model improvement we do on the basis of factor loading modification indices. So here you can see that E1 is getting loaded on 4 factors. This E2 is again getting loaded on 4 factors. And you can see here, so what we are looking here, that a factor which is getting loaded on many factor, cross loading is there, but with a very high value of this modification indices. So if I see this is 40, 22, 18, 4. Similarly, you can see this is 22. If you come down, you can see here, this is the 19, 10, 27. So all 68. So you can see this is the largest, I think, highest value, which I can see. This is the 68. So A7 is getting cross-loaded also. And it's this modification in this index is also very high. So I may take a call to just remove this item and see whether my model has improved or not. So for this, you need to duplicate your data because otherwise it will disappear. So what I'll do, I'll just click this whole result, select all, maybe not. So I have selected all, and then I have maybe copy. No, there's an option of duplicate. Yes. So I have just duplicated the result, and now I will take a call to, before I do that, just this is the path diagram. So the path diagram gives you what we have understood. So basically whatever is shown by the circle, that is the latent variable. So this is the construct, or this is the factor 1, 2, 3, 4 and 5. And these double arrow, these shows the relationship between these factor and this arrow also. So you can see there's a double arrow between the factor 1 and factor 5. Similarly, there is a double arrow between factor 4 and 5. And you can see that these variables, they are getting explained by factor 1. So very clear cut path diagram is there. Ideally in AMOS, if you do this, it gives you the value of the beta coefficient. But in this JAMOVI, you will not get the value of beta coefficient, but there is something known as the standardized equation modeling, or SEM, and there they give you that option gives you the exact value of beta coefficient. But right now I am again going to the modification indices, and in this modification indices, what I do now, I will remove this A7. So I will remove this A7. It was 68. So I'll go again here in the data, and this O7 factor. So this was the O7. So I'll move, sorry, it was A7. So this was A7. So it has moved back. Now again, you will see what is happening to the model fit statistics, because whatever action you are doing, you need to check your model fit. What is happening to the CFI, that is the confirmatory factor indices, and what is happening to the RMSCA and the Tucker-Lewis index. So if you see this, again, it is not improving very much. Model fit is almost same, 0.75. It is not. And the other value, if I see the other value, if it was the 0.752 and 0.737. And if you go up, ideally you can keep, yes. So little bit improvement is there from 0.742 to 0.75. So that is your model 2. So now if you again want to delete any other, then you can keep on doing so. And it is an iterative process. So you may delete or remove, not delete, remove some item from this factor to original window, and then see whether the model is improving or not. But in this case, you are not getting a very good fit, because in exploratory factor analysis only, we have seen that this is explaining only 40% of the variance. So yes, A2 also, Bhavna is writing A2. A2 also you can remove that. Maybe I will remove this A2. And actually this was a 50 item. So that's why it's very huge. But maybe if you are doing it on 25 item, 30 item, or maybe 12 item or 13 item, it will not be that huge look. So maybe you can see if I have moved it back, that A2 also, then again it has improved to some extent. So you can keep on doing that and see the model fit. So again, the most important is to measure this model fit and report. Saraswati is writing C4. So maybe I'm just doing randomly whatever you people are doing. So if I move this C4, so remember it is right now the CFI is 0.755, and keep on duplicating the result, or copy pasting this model fit in some other word format. Then you can compare. Otherwise, every time you have to scroll up and see. So like if I am moving this C4 in this window, then again you can see what is happening to the this statistics. So it takes some time. So we can see here, yes, it has improved. Initially it was 0.755. Right now it is 0.760. But it will not be like 0.9, because 0.9 will only be there when it is 0.8 or something. And if the variance, initial variance was also very less, it was only 40%. So that's why it is not a good fitting model. So you can just write that in your interpretation. And then again, the rule is like you should not delete more than 20% of your initial item. Like if the total number of item in this case is 50, then you should not delete more than 10. So up till 10, it is recommended. I mean, it is not recommended, it is permissible. So that's the confirmatory factor analysis. So again, to repeat, a confirmatory factor analysis, what we do, now you are ready with your respective factors, respective items in those factor. So you write it down in on a piece of paper, and then move those items into the respective factor. Right now, don't give any name to the factor, because naming a factor is also a very Herculean task. You need to sit down and think what name do you want to give to this factor. Like Bhavna was also asking, like there were 3 factors in your statistical anxiety scale. So what name should we propose? So that you can take a, I mean, expert opinion also, you can decide, or you can, like, it's more of a qualitative thing. And then you move these items into the respective factor 1, 2, and 3. Keep on adding factor from this window. Go to the options. In the options, yes, in the options, you will see there is an option of full information maximum likelihood. So this is always the default option, and you should keep it as such, because if you click this exclude cases list wise, then any respondent, if he has not given the answer to one question, that whole respondent will be deleted from your analysis. So we don't want that data loss. That's why this missing value method, this should be by default the full information. And this factor covariances we keep at 1, that I have explained. Then come to estimate. In estimate, we are worried, I mean, we are interested with this factor covariances and the standardized estimate that we have shown. Then come to the model fit. In the model fit, you have got chi-square test, the CFI, TLI, and RMSCA. And then this post hoc model, you have to click this highest value above 0.1, because you will only allow the residual to be up till 0.1. Then again, path diagram you can see. And in modification indices, you have to modify it, whatever is the value which is more than 10. So that's the very basics. I'm not going into the very detail of confirmatory factor analysis, because confirmatory factor analysis, again, there are 2, 3 more, like we do it in standard, that SEM model also. But that is beyond the scope of this workshop. Maybe we can have some more sessions on this confirmatory factor analysis. There's a multi-trait, multi-method also, model is also there, but again, we are not discussing that. So I think you can go again in the breakout room and do that CFA. So we have shared a separate file for CFA on 73 individual. So Dr. Naveen, will you please open the breakout room?
Yes, ma'am, doing that.
Excuse me, I have a doubt.
Please say what is the doubt?
Actually, I wanted to know after applying the modification indices below the chart showing the factor loading modification indices, there is a residual covariances chart.
Yes.
How do we interpret this residual covariances modification indices, in which they have, I think it is the expected and the observed value.
Residual. Okay,
Yes,
okay.
ma'am.
I'll just show you. So you wanted this one, right?
1 minute, ma'am.
Can you see my screen?
Yes, ma'am, I can see your screen.
So actually, basically, this is a huge and
the table far below, I think, not this one. The
No, ma'am,
residual
it is below
covariance.
that.
This one, ma'am, I think.
okay.
Yes, ma'am. Yes, ma'am.
Residual covariances. This one you were saying, right?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So in this case, it just shows you this table that the covariance, that residual, that means the expected and observed difference is more than 0.1, and you can just say there were many combinations showing more than 0.1 correlation. Otherwise, in model fit, this has not got very any significant meaning, apart from saying that there were many residuals
Yes, ma'am.
where the value of the residual was more than 0.1. That's it.
Okay.
Yes.
Ma'am, once the modification indices is not showing any factor more than 10, and still the CFI is around 0.85.
Okay, so CFI is 0.85, then you need
So,
to
ma'am,
go back.
we should go ahead with the questionnaire in that case. Because, ma'am, after removing all the items whose value was more than 10, still there was not much difference in the CFI, in the value of TLI and RMCSEA.
Yes, so that is there because if you go to the initial model, like the initial EFA, then
Yes, ma'am.
it depends on the variance also. Like in your case, those three factors were able to explain how much of the variance.
Okay, ma'am.
That is an important criteria, because if that is there, if the variance is less, then it will be difficult to have a good fit, because the one criteria was that it should have at least 60, it should be able to decide at least 60% of the variance.
Yes, ma'am.
So then only ideally we say that we will do the CFA. Just for we can say that for learning purpose we have shown you, but
Yes, ma'am.
those many factors should explain at least 60% of the variance.
Okay.
Is it okay?
Yes, ma'am. Thank you, ma'am.
Welcome. Any other query?
Ma'am, so like what to do when the variance is not meeting 60%? We have devised a questionnaire doing an EFA, and then we found out that that questionnaire is not meeting the 60% requirement. So what I can do, like in the study, in the research, that will increase that? Should I add more questions or do something else?
First, the most easy is to have more samples. So you can increase your sample size and you can redo it. And if that is not, even if that is not helpful, in that case, you can again sit and see the theoretical construct once again, decide. But again, that is going to add up a new thing. I mean, so in that case, maybe you can try. That means in your case, it is difficult to measure that construct with that tool. So maybe you need
Okay.
to test some other tool.
Okay, ma'am. Okay, thank you, ma'am. Ma'am, another question. It's a bit theoretical. Actually, I was reading an article on the exploratory factor analysis, and I came across this thing that exploratory factor analysis is composed of this principal component analysis and the common factor analysis. So, in that article, it was in the Sage publication article, it was saying that we should do common factor analysis more, but I could not understand the difference between the two. Like, what is the difference and how it relates to this exploratory factor analysis? Ma'am, you're muted.
There are many software which does this analysis, factor analysis. Amos is there. Then I think there's a PLS, which is also a very common software. And with us, there's a Stata and all other options. So maybe terminology with this Jamovi and R, that is not the common common factor. So if you are saying factor analysis, generally it is composed of exploratory and confirmatory. So this EFA, we do it, we have seen there are three methods of doing it, like principal axis, the maximum likelihood, and the minimum this thing. If there were three options. So if you are doing it using the principal axis, it is called as the common factor.
Okay, ma'am.
Did you get it?
If we are using the principal axis, it is called the common factor analysis.
Yeah, I'll show you. See, this was the factor.
Yes, ma'am.
If I click this exploratory factor,
Yes, ma'am.
then you will see there is an option in there is an option of minimum residual,
Yes, ma'am.
maximum likelihood, and principal axis. So if you use this principal axis, it is known as the common factor analysis.
Okay, ma'am. Okay, okay.
So
Thank
that's
you,
why they were saying that.
Okay, okay. Okay,
You will
ma'am.
see many people, they are using maximum likelihood. So, but we have told you principal axis because that's the most recommended, and that's what you are saying, that you should do the common factor. So both are the same statement.
Ma'am, when do we use a maximum likelihood?
Maximum likelihood, if you ask me frankly, at this point, I'm not very sure that I will answer it correctly. It's a little bit statistical concept, and we have not gone to that much depth regarding its background statistics. So
Okay, ma'am.
maybe we need to read more on those maximum likelihood and these minimal residuals also. But
Okay, ma'am.
that is for sure that principal access we do it most commonly.
Yes, yes, ma'am. Okay, ma'am. Thank you.
Ma'am, I have a small doubt. I don't know if I should be asking this.
No. Please, you can ask anything.
If I
No
want to
problem.
publish, ma'am, if after having learned everything, if I want to publish a paper and I'm
Yeah.
using GHQ 9 or I'm using GHQ 12, so
Uh-huh.
I need to publish only the CFA findings. EFA is not valid here because it is already validated. These questionnaires have been widely used and validated. So
No,
what I have
but still, I'll show you one study. It is up to you. Like if you can take those many samples, like see, the difference is you have to take those many samples also. So like I'll show you one article. They have done EFA on Chinese civil servant. We have shared that article with you, I guess also. So in that article, you will see that that person did EFA on sorry, there was some discussion going on and just
no
so
issues.
this no, sorry for that. So that paper that says that you can do the EFA even if it is established one, but your sample that is not thinking in the same way. Let me share. I'll share that article with you. Rather, I wanted to share it with everyone.
We have to do it on two set of samples, right? So it will be double the effort because we need
Yeah.
separate people for CFA and separate
Yes.
for EFA, right?
Yes.
Okay, got it, ma'am. So we need a larger sample size. The population has to be
Yeah.
more.
See this article. Just wait. This was a factor structure of a 12 item. This got published in 2016. Can you see the year? This was a factor structure of a 12 item general health questionnaire in young Chinese civil servants. So, excuse me. If you see this, they have written that the general health questionnaire is developed by this, and it was initially developed as a single dimensional. Okay. So, and they have reported this thing. Now, their objective was they have now written the existing factor structure of GHQ 12. If you see their statistical analysis, research objective, I'm not just focus on this part, statistical analysis. So now what they are writing that then they conducted a reliability analysis of GHQ 12 scale. Finally, they used factor analysis to explore and validate the GHQ 12 factor structure of the respondents. In factor analysis process, they took total sample of 1051 and they randomly split that into a exploratory factor analysis and a confirmatory factor analysis, because they in a 12 item, they must have thought that no item will be deleted because 12 is already a very small number. Ideally, if the questionnaire is long, then you may take a call to do first EFA and then take another sample using that EFA tool which you have finalized. So you may publish two publication, like one of EFA and the second or same tool using a CFA. But obviously the sample size will be different and the subjects will be different. And then you can say that analysis by SPS is 19. Then the EFA was conducted to explore the underlying factor structure of the GHQ 12 in the EFA sample using the principal axis extraction method with the Varimax rotation, parallel analysis method. They have written all those detailed. And now what they did, they compared it with already there were many other like Hankins and Gratz. They have given some other factor number of this GHQ 12. So they have proposed model based on their feedback also. So now they have, if you see,
we can do it. We can
yes,
do it. It is not wrong, no?
No, not at all. You can see here, they have first given the descriptive, then they have given the correlation Cronbach alpha, the same which we have learned, and then you can see the factor loading. So they have extracted three factors.
EFA also and CFA also. All three things, right?
Yeah, this was the, yes. CFA, this was the CFA model, the goodness of it. And they have shown that you can say unidimensional model. They have tested all. And they have given the value of CFI, TLI, RMSCA, chi-square value, their value. Okay. So you can do.
Share model with the other models.
Yes.
Okay. Right. Thank you, ma'am. Thank you. Got it. Thank you so much.
Welcome. So I think all of us are back to the main room. Yes, and so how was your experience of doing this CFA and EFA? Yes, so now it's your time to say. So yes, I think there were few people who were not speaking. Saraswati, Dr. Saraswati, how was your experience of this doing EFA, CFA? Could you understand something?
Yes, ma'am, as usual, like even the difficult concepts, you make it very easy to understand. But when compared to other it's just a feedback, ma'am. When compared to other SPSS advanced and the basic, this was little difficult.
Yes, this was difficult, very rightly said. This was difficult for us too.
Yes,
Because,
ma'am.
and right now also we have not told you everything, because there are 2 more steps which we have deliberately not covered. Maybe in the next, because I will request all of you to plan at least one study and to do one publication of any skill, maybe the EFA, the simple one, like Dr. Bhavna was thinking of doing a PHQ 9. So you can do, because that's only a 9 item question. And then once you do it, because see, those concepts, this is not a very commonly done by all
Yes.
of us.
Yes.
Like
Only
before
when we do it, will be more clear, ma'am.
yes, because all those concepts we were in habit of doing, right? You know, regression, ROC, logistic. In everyday life, we keep on talking about those concepts and we keep on applying and reading. But this scale development was very new for us too. Like, let me share this very frankly with all of you, that we only started preparing for it after you guys gave us the feedback that you wanted a workshop on this factor, like questionnaire development and validating the scale. Before that, we have not thought of it. So thanks to you people, we also learned a lot. And maybe because we are also lacking a lot of practical experience now, because we have read it, we have delivered it, but now we are also planning on this statistical anxiety tool, maybe the stars, which we have started. And then we may do some work, keep on doing some work, reading, and then maybe all those concepts will be, embedded. Definitely it is not a very simple concept, like you said. It takes some time, maybe it takes time rather, for everyone. All of us has to go through that process.
Yes, ma'am. Thank you, ma'am.
Thank you. Any other participant? Kavita, yes, Kavita. That will be the next announcement. Systematic review. But before that, we wanted to publish a paper. That's why we are waiting. So we are onto it. Once we publish that, then we'll hold a workshop on, definitely on systematic review and meta-analysis, because we don't want you to tell only theoretical thing without experiencing it. So we have not done any meta-analysis, but we are doing it. The meta-analysis, once we'll publish that, then we'll definitely have a workshop. It is in pipeline. Kappa statistics, I think we have taken that one workshop on Kappa statistics. Okay, Ekta is also writing. Yes, anybody who will, I know that a lot of concepts are still get to be cleared. Because that SEM model, that standard, which I talked, we have not covered that. That option is there in Jamovi, and that's a very good option. So that will take another, I think, 2 days to explain that. So maybe in the next time, we will add that session also in this part, because still that is left. So any other query from your end or any other feedback? So yes, before we conclude, yes.
Ma'am, we recently did a study using PHQ-9 on COVID-19 survivors.
Okay.
And that paper is due for publication.
Mhm.
Can we use the same sample in which we have 150 responses for EFA?
Yes, you can. You can.
Right.
Although in your limitation, you may write that the samples, because we always write in the limitations of our study. So in that limitation, you may write that sample size was not adequate, but definitely you can publish.
The fact that there are only 9 items.
Oh, 9. Yes, yes. 9, then the 160, I mean, number that is perfect. I'm sorry. Yes, you are right.
And ma'am, now the feedback. Thank you so much. I've learned a lot from you. And I think I'll have to personally come to Patna to thank you. And I will
No,
definitely
thank you,
do
Bhavna. Thank you. Like, you people keep us motivating also. Thank you so
No, ma'am,
much.
it has been a pleasure and learned a lot. Thank you. All thanks to you and your team. Dr. Hamad, everyone, all your SRs, everyone. Thank you so much.
Okay, thank you, Bhavna. Thank you. Anybody else who would like to give some future recommendations? Because that, we only move ahead with your feedback. So Nitesh is writing something.
Ma'am, this is Dr. Sugandha from KGMU.
Yes, Sugandha.
Really want to thank you, ma'am, for an amazing 3 days knowledge learning session. And ma'am, it was, we were like, the best part was the hands-on, because that was very practical. So whatever theoretical we learned, we were able to apply it. And personally, I like the Jamovi software. Means it was means doing the factor analysis on that software was means I felt it was quite easy. And ma'am, I wanted to know that can we contact you in future if we do some analysis related to
You can,
EFA, if we have any doubts, anywhere we want some guidance?
Definitely, you can write to us at support@meritindia.com. We'll share that mail.
Yes,
and
ma'am.
That is there in the website. You can definitely write and we'll contact you. We'll definitely give the answer. We'll respond.
Okay. Thank you, ma'am. Thank you so much, ma'am.
Yes.
Ma'am?
Yeah, Nitesh, I think Nitesh was writing something now. Can we use it during analysis part to include the variable based on EFA and CFA? Oh, yes, definitely we can. There's a lot of scope. It's like, although we say like CFA, EFA should be done on unknown, but you have seen that article, and we have seen many articles where already the factor was known to the people, but still they wanted to check it in their respondent. Okay, so Haripriya is asking that interpretation of post hoc model and modification indices. So that I have explained that this post hoc, it was the residuals. It is only to say that proportion of residual which was more than 0.1. So that shows the less, you can say, in between factor, that what was the difference between the expected and the observed. That was regarding the this post hoc covariance analysis. Any other feedback from your side? For any like, apart from all good, anything which we should have improved, or you felt that that should have been in a better way, that will help us really.
Ma'am, good afternoon, ma'am. Dr. Poonam here.
Yes, Dr. Poonam.
Ma'am, as we have attended almost all the workshops, and as all the workshops were excellent, and this too was really good, ma'am. Regarding one thing, regarding the validation of the questionnaire, ma'am, what I feel is like, which was actually done practically, ma'am, that if we get to know that there was one questionnaire before, then the validation was done, like how it was done practically, if that is shared, then that will be easy for us to understand, ma'am.
Means any that that article you are asking about, any article where they have published how. Yes, we were, I think we have shared article. Have you gone through that shared content?
No, ma'am, not
okay
yet.
Then it is there in the website. We have shared that those articles with you, the another reading resources also, which will help you to understand the process of developing, and we have shared 2 books also on the scale development. It will help you.
Yes, thank you.
Those 2 are the best book on the scale development which we have shared. Maybe it will take time to understand. One, like it's more, see, it's a combination of qualitative, which you have attended, and a hardcore quantitative. So it's the scale development has both these, because we talk about construct, we talk about, some underlying latent factor, which is difficult to measure. And in qualitative, we talked a lot about those latent variable regarding perception, regarding opinion, regarding happiness. And in this case, you are, clubbing these two techniques together. And that's the beauty of, the structural equation modeling, SEM, which we'll see, which combines both these latency and this modeling together.
Yes, ma'am, absolutely right, ma'am.
Okay, so so before we conclude, there's only one announcement. We'll share one data set with you by Saturday, and all of you, those of you who have registered, we will send you 10 questions, which will be based on that. It will be a skill based, like analysis part, the values, maybe the based on that data set, you need to answer that. Once you submit that response, it is just an assessment, you can say, then you will automatically get the certificate. So the certificate is only, you will get it after you submit your answers on Saturday. You may delay it also. We will open it on Saturday. If anyone, if you could not take on that day, it will be open for 15 days. And like for 2 weeks, all of you can appear and give that test or whatever you can say, assessment, and then that certificate will be issued. Okay. So I think then we can conclude this workshop if there are no further.
Ma'am, Dr. Poonam here again, ma'am.
Yes.
Yeah, regarding the sample size series of webinar, ma'am, there are some articles to read with every section, ma'am, cross-sectional, case control. But the article to read, if I am going to the cross-sectional studies, I can find the RCTs and all. It's like a mixed thing, ma'am. If it is sorted out, that will be like, if it goes with the cross-sectional and the articles to read, if those are of cross-sectional, that will be helpful for, ma'am.
No, can you repeat your question or the response? I didn't get, Dr. Poonam.
Ma'am, in a Merit India website, I'm talking about the sample size webinar series, ma'am.
Okay. So sample size, we are again going to have another session on GPAR software, and we will, so feedback what you gave, that cross section.
The articles to read are shared, ma'am.
Okay.
With each section, like cross sectional, we have, you have shared few articles to read.
Okay.
Right? But those, what I was assuming that those will be the articles on the cross-sectional studies only, ma'am. Sample size related
but it is mixed.
But it is mixed, like we are struggling to find those, ma'am. If it is sorted out, then like case control articles in the case control section. That
got it. Now I totally got it. So I will, we will, not I mean, we will do it. We will sort it. And I hope it just give us, I think, how much time it will be? 1 week? Maybe 1 week time, we will sort it out.
Yes, thank you, ma'am. Thank you.
Kavita is asking workshop, Mr. Jamovi. We may conduct it. Otherwise, you may see the videos. Videos are available over the YouTube. So you can see that. So you will learn. Otherwise, we may have a workshop. Then you all will be informed. Those of you who missed it, you can again join. We are trying to make a course on Jamovi also, which will be free for everyone. That will be LMS based course. So you can even, it might take some time because, we always say, and we are always delayed. So maybe that will be there, but again, we'll try, we are trying for that. Okay. Thank you, Kavita. So if there are no more, any other participant wants to say anything? Okay. If not, then I think thank you to all of you. And hope to see all of you again in future. So good day to all of you. Thank you.